Hello everyone, welcome back to the channel. We are doing Leetcode 713 subarray product less than k. Given an array of integer nums, something like this, and an integer k, return the number of contiguous subarrays. Subarrays by default are contiguous, so again an extra word. Return the number of subarrays where the product of all the elements, in the subarray is strictly less than k. And this question is very similar to subarray sum less than k. So for example, I could have asked you, return the number of subarrays where the sum of all the product where the sum of all the elements in the subarray is strictly less than k, or if it's greater than equals to k, something like that as well. So let's take a look at what the first test case looks like. Okay, so I have 10, 5, 2 and 6. Right, now I need to find out the count of all the subarrays which have a product of less than k. Now, since I'm talking about subarrays, since I'm talking about contiguous parts of the array, so for example, this might be 1 and this is 50. This might be 1 as well. And what we are observing is 5, 2 and 6, 60. This is 1 as well. 2 and 6, 12. This is 1 as well. And all of these individual elements, 10, 5, 2 and 6, uh, they are individual subarrays as well, which have a product of less than k. So just visually first, just without any logic, let's just first visually try to see what's the answer for this test case going to be. So it's going to be 10, 5, 2 and 6, all these individual arrays. Okay, then it's going to be 10, 5, okay, 5, 2 and 2, 6. So 4 plus 3, perfect. Then it's going to be 10, 5, 2, no, because that's exactly 100. But 5, 2, 6, yes, right? So plus 1. And then 10, 5, 2, 6 obviously does not constitute the answer. So this was sort of like the brute force approach, right? The brute force approach says that you calculate all the subarrays, all the possible subarrays, you calculate their product, and then you see that if that product is less than k or not. But let's have a look at the constraints. The constraints are 3 into 10 to the power 4. Okay, let me write that down over here. 3 into 10 to the power 4. And the brute force approach, which says that calculate all the subarrays, pre-compute all the subarrays, that is an O of n square. Clearly an O of n square strategy, right? So if I square 3 into 10 to the power 2, that becomes equals to what? 9 into 10 to the power 8, which is greater than 10 to the power 8, so it won't get accepted. It is going to give you a time limit exceeded error. So that is why we cannot opt the brute force approach. If the constraints were a little smaller, then we might have gone with the brute force approach, but then we need something which is more optimal. So let's have a look at that. Now, whenever we are talking about subarrays, there is this very common, a very natural urge to go with a sliding window sort of an approach, isn't it? Because sliding window sort of is like it's made in order to calculate subarrays and in order to process and work with subarrays, right? So, and that's what exactly I'm doing, right? So this is a subarray and this is a subarray. So it can start with I, it can end at j, something like that. So let's try that. I will initialize two pointers I and j, okay, at 0, at the 0th index. I will be calculating the product of each and every subarray, and overall I'll be seeing in this answer variable, I'll be keeping track of how many of those subarrays have a product which is less than k. Okay, now the product of this particular subarray is 10. So I am going to update my product. It becomes 10. It is less than k, and I'm going to say that I have one subarray such that its product is less than k. Okay, then time to expand my window. I increment my j. So product becomes what? I'll just multiply the 10 by 5, becomes 50, and then 50 is less than k as well. So I should increment my answer by 1. No, not by 1. I'll tell you why. You see, 10 is something. This subarray is something which I have already selected. But then when I expand my window, I am getting two new subarrays which have a product less than k. One is 10, 5, and the other one is 5 alone. You see, I'm getting two subarrays which have a sum of less than k. So I don't need to increment my previous answer, which was 1 by 1. I need to increment it by 2. So it becomes 3. And if you notice that the window size is also equals to 2. So I am basically incrementing my answer each time by window size, not by 1. Okay, perfect. Now let's expand our window. I'm going to multiply 50 by 2. It's going to become 100, and 100 is actually the product of this particular subarray. Now the thing is, 100 is exactly equals to 100, which is k, not less than that. For a moment, let's say that this k was 101. So this would have been a valid subarray, right? In that case, I would have gotten 3 new subarrays. 1, 2, and 3. 3 new valid subarrays which have a product of less than k, if k was 101. Okay, so I would have made this equals to 6. I won't do that. Why? Because k is equals to 100. So now what do I do? When the product of my window becomes equal to, or if it becomes greater than k, what do? I need to shrink my window, right? And how do we shrink the window? You know that I'm going to take my I and place it over here. But before I increment my I need to divide the product by 10, right? So that it becomes what? 100 divided by 10 becomes equals to 10. Then when I increment my I, it makes more sense. Why? Because the product of this particular subarray is 10 as well. So, this number was exiting my window. So that's why I divided the product by this number, because it needs to exit my window, right? Whenever some new number gets introduced to my window, I multiply the product by it. So I'm basically sort of trying to take a cumulative product, right? So I need to make sure that when I'm shrinking my window, I need to do the division operation as well. Perfect. So this is my new window, 5 and 2. And let me erase this. This is my new window, 5 and 2, and its product is 10. Its product is 10. It's less than k. So I'm going to increment my answer by how much? By 2. Perfect. Then I expand my window, 5 into 2 into 6. What is that? 60. So I'm just going to multiply the current cumulative product by 6. It becomes 60. It's less than k. The window size is 3. I increment my answer by 3. I increment my j goes out of bound, and that's the end of my procedure, right? So 8 should be the final answer, and it is the final answer. So it's a very simple question. It's medium mark, but it can be regarded as a very simple question, given that you know when to use sliding window and how to actually you know uh, see how the sliding window technique works. Okay, perfect. So how do we implement this? It's actually pretty simple. Let me open up the coding environment at this side, and this at this side. So what do I basically do? If I start from the very beginning, what am I actually doing? My product is 0. Sorry, my product is 1 actually, and I have initialized 2 pointers like this. The first thing that I do, something that we know, is I need to have a while loop or a for loop, because I'm incrementing my j at each and every iteration, right? So let me just write that for a while loop over here. It could have been a for loop as well, but then it's just my habit that whenever I'm working with sliding window, I prefer to use a while loop. So just a matter of habit. You could very well use a for loop over here as well, right? So I have product as 1, answer as 0, I and j as 0, and then n is just the at nums dot size. Okay, perfect. Now the first thing that I do is I say product should get multiplied by what? Nums of j. When I do that, what the product becomes equals to? The product becomes equals to 10, right? Then what do? I check if the product, if it's less than k, if it's strictly less than k, I need to add something to my answer. And what do I add to my answer? I add the window size. So before that, I need to calculate what the window size is, isn't it? And window size can very easily be calculated by what? What's the window size over here? It's 1, right? So, and again, for example, if j was at this point, so 0 and 1 index, the window size would have been 2. So it's nothing but j minus I plus 1, right? So standard procedure, j minus I plus 1, and I need to add that to my answer. Perfect. Okay, so I added 1 to my answer. My answer has become 1. I increment my j. Okay, perfect. Product becomes equals to 50. 50 is less than 100, so I add 2. Window size is 2, so I add 2 to my answer, it becomes 30. Then again I increment the j. At this point, what happens that my product becomes greater than equals to k. Okay, my product becomes greater than equals to k, so I need to shrink my window. I need to do what? I need to shrink my window, right? So what I'll do is I'll just have a while loop over here, and I'm going to say while product is greater than equals to k, you need to do what? You need to divide the product by nums of I. You need to divide the product by nums of I, and then you need to increment the I. So when I divide the product by nums of I, it becomes equals to 10. Okay, and then I increment my I. That's it. My product has become less than equals to k. So it's no longer greater than equals to k, right? And similarly, this is a new subarray. So if product is less than k, I calculate the window size. Window size is 2. I add that to my answer. It becomes 5, so on and so forth. Then I increment my j again. The window size is 3. I'm going to add 3 over here. It becomes 8. J plus plus. When I increment my j, it goes out of bound. I exit my loop and I return my answer. So if I submit this particular code, let's see if it passes all the test cases. Right, it very easily does. And if we take a look at the time and space complexity, what do you think, by the way, is going to be the time and space complexity of this thing? So for the space complexity, it's very simple, right? It's just O of 1, because we are not taking any extra space. We are just using two variables, I, j, and the cumulative product and the cumulative answer. So the space complexity is clearly O of 1. And about the time complexity, you can very easily see that we are just visiting each and every number at most twice. At most twice. So once when I introduce that number to my window, and second when I sort of exit that number from my window. And there are some numbers which do not get exited. For example, these two numbers did not get exited from my window because the j got out of bound before that. So at max, I'm just visiting every number 2 times, so it's an O of n time complexity, right? So I hope you found the video helpful, and I will see you in the next one. Take care.